to show that all your drop is just visual and it's not actual, because it doesn't add up. This is kind of the same, so this one's a little simpler. Shadow Bevet his Pemrose drop gets people to think. All right, so you start here, and you're gonna go. Now, when you get here, this is a mile. You will have dropped 0.67, right? That's your drop.
Okay. Now let's assume, okay, when he says you would have dropped a mile, let's say he's talking about a foundation for a building they haven't built yet, and let's just say it's exactly level. Let's say it's on a lake, in the middle of a lake, and the building foundation is exactly level with the water. Okay. Just hypothetically speaking, so he's saying it drops, you would have dropped 8 inches. So the foundation from one end to the other would have dropped 8 inches down. Okay.
Now, if you sight yourself back to where you were, right, back to that dot, and then go to it, you'll drop again, because it's always dropped, right? So then now you drop down another 0.6. So you sight back to where your original. That other spot, then you go back over there, you'll drop again, right? And then you look back, and you'll drop again, right? And then you'll look, and you'll drop again. Now, that what we just showed, that's not a ball.
Wait a minute. What are you doing? It doesn't work like that.
So this is what they have to show. I mean, I'm going to say, I got called out by, I think, Cleary, my bud, either way. He thought I was trolling, man, and like sticking up for the ball by saying that the math works out. And to elaborate on that, the spherical geometry, okay, they found, the mathematics to make it match out, but that comes with angle changes, okay, and that also brings its own set of problems that are catastrophic to the model. And I like what Right the Hand did here, is he picked just 1 mile. Instead of shooting out, miles and miles, 3 or 4 or 5, he just picked 1 going back and forth to show that they have to assume that they're changing angles, okay? And then on top of that, who's to say how much it is changing? What tells the difference? Okay, if you're trying to measure the drop, okay, and you have an auto level and you're looking out, or even a laser, okay, and how do you distinguish between earth curvature and the drop of the ground? There's no way to distinguish it except for mathematically, okay, because you need a starting point to begin with, okay, and that's what they do. And what Right the Hand is pointing out in this video is that their model is strictly mathematical, and I 100% agree. So you see Blue's drawing right here, so he has to assume that the cletus at one end of the foundation is angled differently on the same line. Now, take it on the same line, the same foundation, but it's angled differently than the other cletus at the other end. And that's the only way they can make it work. And like I said, that comes with a whole new set of problems, and I drew it out on a board. I'm gonna show you, but let's listen a little bit more.
Boy, Cletus is over here at point A. His tangent is this red line that he's standing on right there, and the drop to point B is that blue line way over there. But if Cletus's other brother Cletus is standing at point B, his tangent is not down below the earth someplace. It's tangent to the surface he's standing on. It's this red line, and his drop is this drop over here at A. This does not work the way you're showing it.
Okay, that's like stairs. So that alone shows me that you're not seeing a physical drop, right? Because if it was physical...
And I want to say this too, okay, while we're on the subject here in this video, I want to say that if you took an auto level and you set it up at 5 foot above the water, okay, or above the water foundation, whatever you want to call it, and then you took another one a mile away and you aimed them at each other, okay? Now, if they are pointing above each other, leveled out, then that would, if they're pointing above each other, okay, then that would mean one of two things. Either light is angling, bending or angling, or the ground, the foundation, the water, whatever level is angling. One or the other. There's no other options. So, and now, by the simple fact that when we go and set up our auto levels and look off in the distance, or even with cameras, we see the horizon changing all the time. So in their model, it has to be the light angling, bending, whatever you want to call it, changing, and the ground. They need both, okay? Because they can't deny the fact that the horizon is moving up and down, okay? Now, on a flat Earth model, it's just the light that's bending. The ground, the water is level. It stays level, undisturbed. And the further you go, and the light's always changing. And so, like I said, on the globe, they need both, because they can't ignore. They tried to ignore the fact that the horizon was moving around. The black swan killed that, and it's got them double speaking, and half of them don't even understand that they're double speaking, man. But that's another video. But I'm gonna listen a little bit more, and I'll show you what I meant by the math being the same with angle changes.
When you went this way and looked back, you would see physically up.
Yeah, you do see physically up, just like I showed you.
Right? Because if you're here and you're going around, you're going down. If you go down and you do the opposite, you go back up. That's how physical structures work. You can't just keep going down, right? It would keep. How would you keep going down? If you.
Okay, so like I said, shout out to Right the Hand, and shout out to Bev, Try Thinking, trying to point this out. And once again, I like how he does it with just a 1 mile horizontal to show that they're having to assume the angles are changing. They can do that mathematically, but in the real world, it does not work. Okay, it is a mathematical model, and I'm going to demonstrate why right here. Okay, so what I have here is basically this represents the earth, or the ground. Let's call it the water or whatever. These are little auto levels, right, on tripods. Auto level, auto level, auto level. Okay, now if that's supposed to be leveled out, an auto level leveled out, okay, number one. Okay, and them little sections, them little poles are poles above the water 5 foot. So I got little 5 foot marks where it says 5 foot, little auto levels shooting out. Okay, and that shows where the auto level itself is 5 foot tall. So it's exactly level with the little 5 foot rods. Okay, now if they were to go, let's say these are 1 mile increments. Okay, so 1 mile, they say if you're shooting, I mean, I know you don't go a mile, but just hypothetically, we're calling this a mile. They say that when you're surveying with your auto level, you're changing angles each time, right? So you shoot a mile and you're 5 foot, and then you back shoot 5 foot. So you have 2 poles that are exactly 5 foot tall above the water. Okay, that means the water's level. Now when you go to your next spot, you back shoot the first one you shot, and then you shoot out to your next one, and it's 5 foot. Okay, so they say that you're changing angles, you just don't realize it. So they say you're changing angles each time you set up your instrument, but you just don't realize it. Now, and this is how it works out the same. So this would be if the water is level down here. Everything works out the same, 5 foot above the water. But in this one, you're not changing angles because the ground is not angling. Now, if you get to the end of this one here, say if you shoot further than 1 mile, okay? Like say number 4 shoots its mile and it's 5 foot, that stick is 5 foot. But let's say you go out to the next stick which is another mile, it's going to be shooting just for shits and giggles, just say 7 foot. Okay? So the only way the math works is if each time you set up your auto level, you are shooting in that exact straight line, for one, and number two, you're shooting the exact same distance, or else you're going to get differing, or else them poles are going to show you different heights or elevations. And here's another way to demonstrate it. Okay, so I drew like basically an octagon. Okay, and each one of them little shaded things are a building. Okay, now if you do the same distance lines around the ball, then they're all hitting about the middle of every building, right? So they're hitting the middle, each line is hitting the middle of every building, each one of them little square pieces. Okay, and you're just changing angles. So each we'll call them buoys on the water. So you're hitting about halfway. Let's say they're 10-foot buoys, you're hitting 5 foot. Smack dab on every one of them. Okay, now over here did the same thing. So you start off and then you do the same distance for 9 and for 10 and for 1. Then you start changing your angle. Okay, so or you start changing your distance. So if you don't go the same distance as you did for let's say 8, 9, and 10, see we're hitting the middle of the buildings. You start changing the distance. Now you're hitting lower on the buoy or the building, whatever you want to call it. Now, too, if you see what happens when we change distances. So you start. Now I'm hitting the bottom of the building. Okay, and the point of this is, the whole point of all this is that their model works hunky dory on paper. Okay, on paper it works fine, but in reality, they say they do curve corrections to planar surveys. That's bullshit, because every survey and every shot in every survey would have to be the same distance and on that same line. Okay, so they'd have to pick a line of latitude or whatever line and maintain that line, and they couldn't match up anything. It would fall to pieces. So when Right the Hand says it's mathematical, he's spot on. In reality, there's no way you could maintain an exact straight line surveying out in the real world, much less maintain exact same distances. But you see right there, the distances change. If the distance changes, then the elevations would change. It would not work out the same, and that is catastrophic. So yeah, mathematically, yeah, that's great. So that's what I meant when I said that mathematically they can make it work out, okay, like here. But in reality, okay, it would never work out. It's not, to me, it doesn't even seem possible. So they basically are taking a shit when they're saying curve corrections to the planar surveys. They're taking a shit on our forefathers. That's my opinion, man. But that's my opinion on them taking a shit on. But it's factual, saying that if you change the distance between shots, you are also changing elevations, mathematically speaking. Thank you.